Good afternoon, everyone. Am I audible to you clearly?
Yes, ma'am.
Am I audible to you?
Yes, ma'am.
Yes, ma'am.
Okay. So, after a long time, we met today in the session of basic mathematics. And first of all, I welcome all the students who have joined newly. For them, this lecture is first lecture, so you can text me on WhatsApp and I'll share the videos of previous sessions. I'll share link with you. So after this lecture, you just say hi to me on WhatsApp and just note it down that you want uh, previous video lectures. So I'll share the link with you, and according to that, you can revise the things. And if you get any doubts from that from previous sessions, you can ask me anytime after our lecture finish. Okay, so what we have seen in the last session, anybody remember what we have seen in the last session? Okay, so let me tell you what we have seen. We have done some examples, mixed exercise examples of a set theory, union, intersection, complement. Okay, so this is we have seen in our last session. Universal set, then three sets given to us, then we have calculated A union B, B union C, then power set of A, power set of C, A dash, B dash, uh, symmetric difference of two sets, intersection of two sets, and so on. Okay, so before starting the next topic, let us revise something. Here I am writing in the screen. I just want to check that if you remember every concepts or not, that's it. We have the set 1 comma 2 comma 3 comma 4 comma 5, and set B is 5 comma 6 comma 7 comma 8. Okay, one more set I want to give is universal set, which is 1 comma 2 comma 3 comma up to 10. Okay, so you have to write down in the chat box that what will be A union B. Find A union B and A intersection B and A dash and B dash. Okay, all these terms you have to find out and write in the chat box. Edward is not able to see the screen. You can leave the meeting and join it again. I think there's some connectivity issue from your side. Okay, so this is Mansoor, Sagar, Amit. A union B will be 1, 2, 3, 4, 5, 6, 7, 8. Yes. Now you find out A intersection B, A dash and B dash. Whatever you are writing, you just mention that for what you have written this answer, like that. Okay, A intersection B will be, everyone have to write down A intersection B first. What will be A intersection B? Intersection means common elements in both the sets. So there's only one common element, which is 5, is common in both the sets. So A intersection B will be 5. Okay. Now we need to find out A dash. A dash means what? All those elements which are in U but not in A. So we have to find out uh, U minus A. So what will be A dash? We just have to do U minus A. So all those elements which are in A, we have to delete it from universal set. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 minus 1, 2, 3, 4, 5. So ultimately it will be 6, 7, 8, 9, 10. Okay, so this will be A dash. Now you have to find out B dash. What will be B dash? Okay, B dash will be 1, 2, 3, 4. Then we'll delete 5, 6, 7, 8. Then 9, 10. 1, 2, 3, 4, 9, 10. Yes. So this exercise is just for revision. Okay, now let us see the next topic, which is algebra of sets. So this is algebra of sets. We have some laws over here. Law of set theory. Like first of all, first law is idempotent law. So now this is very simple law which we can definitely remember, but just we need to do it, that we have to remember the statement of a particular law. Like we have three or four laws. So which law is containing which statement, that we need to remember. That's it. So the first law is A union A equals to what? Now if you have two sets A and you are finding union of with itself. So A union A will be what? What will be A union A? If I am having this set,
A itself.
yes. If set 1, 2, 3, 4, 5 I am having, and I am doing A union A means 1, 2, 3, 4, 5 union 1, 2, 3, 4, 5. It will be the same as A. So this is A union A will be A. Now the next is A intersection A. What will be A intersection A? Common elements between two
A.
sets. Again, it will be A because here see, we have A equals to 1, 2, 3, 4, 5. Again, I am doing intersection with the same set 1, 2, 3, 4, 5. So, common elements will be the whole set, which will be A, right? Clear with this idempotent law?
Yes.
This
Yes.
is this is very
Yes, ma'am.
easy to understand, but this can be difficult in our exam to remember it. So you have to put it in your mind that idempotent law is A union A is A and A intersection A is A. Here they have given one example of set A which containing only two elements 1 and 2. A union A will be 1 2, A intersection A will be 1 2. Okay, now the next is identity law. So identity law means what identity will uh, react with the set. Now see, we have universal set U and we have set A. Let U be the universal set and A be any subset of universal set. Then what will be A union null set. What will be A union null set? See, null set is the identity element of union operation. So what will be A union null set? See, I am having one set. I'm taking over here. Okay, I'm taking over here. This is A equals to 1, comma 2, comma 3. And I am having one more set which is null set. Okay, let me do this. A union null set equals to A I am having as 1, 2, 3 and union null set. What will be the answer of this question?
A.
It's one, two,
A.
three.
It's 1, 2, 3, right? Okay. So that means null set is the identity element for union. Union operation, in union operation, if I am doing any set union null set, it will give me the same set. So A union null set will be A itself, right? This point you got it clearly.
Yes, ma'am.
Yes,
Yes.
ma'am.
For any set, if I am finding the set union null set, so answer will be the same set. Okay, that means null set is the identity element for union. Like identity element means what? Let me just clear it out, because we have some regular operations like let us take addition. So what will be the identity element for addition? That means what? Any number I'm taking, suppose I'm taking 5, and what should I add with 5, and it will give me the same 5. What should I add over there?
Zero.
0.
Exactly, 5 plus 0 will be 5, means 0 is the identity element for addition. Are you clear? Identity means what? The number will be the same. Operation I'm doing, but it is identity element. It will make the answer same as we have taken. Like, let us ask me one more question. What will be the identity element of multiplication? Means what? If I'm taking the number 7, what should I multiply with 7 will give me the 7?
One.
1.
I should multiply 1. That means 7 into 1 will be 7. So 1 is the identity element for multiplication. So every operation is having their own identity element. So addition is having identity element 0, multiplication is having identity element 1, union is having identity element null set. And now let us go to the next, which is intersection. What will be the identity element for intersection? Like if I'm taking any set A, and what should I intersect with it, and I will get again A, and it should be in general common for all the sets. What should I intersect with A? Are you getting any idea?
Yes.
What?
A itself.
A itself, but if I'm doing A intersection A will give me A, okay, but if I'm changing the set, like if I'm taking B, then I should, what should I do with B intersection? Again I have to change the set, which is B, because B intersection A will not be B. Here see, the null set is the common element for everyone. You get the idea what I'm trying to say?
Yes.
For any set I'm taking null set and it will be the same. So what should I intersect with this every set, and I'll get the same set. It should be common.
Okay.
Ma'am, can we take
Ma'am,
universal set?
Answer is in the screen only. What?
uh, I've got a question, ma'am.
Yes.
So, does it mean if you've got two sets, for example, set A and B, and then
Hmm.
you're asked to find the intersection of both
Yes.
the sets, is
Hmm.
it correct according to your identity? law to say the intersection is now set?
No, identity element is not saying that. Identity law means these are the laws which contains the statement, and the statement is that for every set we have some identity element. Identity element means what? That if I am operating this element on set, answer will not change. Like if I am here, I am having set A. In the first law, I am having set A over here. I have to operate. So operation is union. Okay. I am operating with what? With null set will give me A itself. And what that is what I want. I want to operate it. I want to operate some element, but answer should not change. So A will be A only.
Okay.
Are you clear? Now I want
Yeah.
something like this. In the next statement, I want something like this, that I want to A, just a minute, intersection something. Here I am putting the blank. You have to fill this blank. This is what should I get. Like I want to intersect something, and that should be in general for every set. If I'm putting B, if I'm putting C, the blank should be the same. This answer should be same, and answer will be the same set.
Okay.
Ma'am, uh, I
Yes.
think it is universal set.
Yes, this is universal set. Great. Like if I'm finding A intersection universal set, it will be A itself because we are finding common area. You get the answer. See, this is the
Yes.
second law of identity, second identity law. A intersection universal set will be A. And if I'm changing B over here, no problem. B intersection universal set, again it will be B. You get it? If I'm putting this B, okay, I'm changing B. So B intersection universal set will be what? It will be B. So intersecting with universal set will not change the answer. And so universal set is the identity element for intersection. Here we have example. Universal set is 1, 2, 3, 4, 5. Set A is 1, comma 2. Now if I'm finding A intersection universal set, means 1, 2 intersection 1, 2, 3, 4, 5. For intersection, we are taking common elements only, and here common elements are 1, comma 2. And that means this is set A. Are you clear with identity law?
Get yes.
Yes, ma'am.
Okay. Is there any doubt by your side? Anybody have any doubt? Then write it in the chat box. Okay. So the next I am going to third law, which is commutative law. So commutative law means what? I can change the places. Simply, I can say that if I'm finding 3 into 5, what will I get? 3 into 5 means
15.
it will be 15. Now, if I'm finding 5 into 3, then
It's again 15.
yes, because I'm changing the place, but answer will be the same. This is called commutative law. If I'm doing 7 plus 3, what will be the answer?
Oh, sorry. Oh, did you
7 plus
say 3 into or 3 by? I don't know. I got lost a little bit. Isn't
what?
3 into division?
I don't get your
I,
answer, or you are not audible clearly, I
I,
guess.
I didn't get you clear on what you said. You said 3
Okay.
into 5
Yes, 3
or
into
3
5.
by 5.
5 into 3.
Oh, okay. I get you now.
Okay. Now tell me what will be 7 plus 3?
It's 10.
Yes, and if I am finding 3 plus 7, then?
It's again 10.
Yes, it's again 10. That means if I'm changing the sequence of writing, it will not change the answer. And it is called commutative property, which all of these operations is having. So, likewise, as we are having in addition and multiplication, in our set theory, we have commutative law in union and intersection also. So, commutative law means for any two sets A and B, A union B and B union A are equal. These two sets are equal. Like we have seen 3 plus 5, 5 plus 3. I've changed the places, but answer will be the same. And the same way in universal union and intersection, we have the property. Here see, we have let A equals to 1, 2, 3 and B equals to 3, 4, 5. So A union B is 1, 2, 3, 4, 5. And if I'm finding B union A, same answer will be the same 1, 2, 3, 4, 5. So we can say that union is commutative, and this is the commutative law. And the same for intersection also, we have two sets A and B. Then A union B and A intersection B are the same sets. So this is what they have mentioned over here. Yes. So this is A union B equals to A intersection B equals to B intersection A. And we have this example, set A is 1, 2, 3, B is 3, 4, 5. Now if I am finding A intersection B, it will be 3. If I am finding B intersection A, it will be 3 only. So I can say that A union B equals to B union A. Now here we have proof of the statement, because to prove something, we cannot take any example. Example cannot prove a statement. We have to prove it mathematically in general. Like if I'm taking this for particular example, then the other example will come, then the other example will come, then the other example will come. So it will not stop anywhere. So whenever we are proving something in mathematics, we have to prove it in general. So here we have proof of commutative law. So the first we are trying to prove that A union B equals to B union A. So we are taking X. What we'll do generally will do is, we will show that first set is A union B will is the subset of B union A. This is what we will show. And secondly, we'll show that B union A is the subset of A union B. So we'll prove it both the way, and then we can say that A union B equals to B union A. If I'm showing that one set is subset of another set, then I'm showing that the second set is subset of the first set. So both the sets will be equal ultimately. So here X be any arbitrary element from A union B. So we have element X from A union B. Now if here I'm having, just a minute, I'm having X belongs to A union B. So first of all, I'll take one element from the first set, A union B. So here I have taken one element, and I'll show that that element is the part of the second set also. So from the statement X belongs to A union B, I can say that X belongs to A or X belongs to B, because this is the definition of union. In union, we have the definition that if X belongs to A union B, then X is either in A or in B or in both. So I have written in the next step that X belongs to A or X belongs to B. Now I can change the places. I can write this way, that X belongs to B or X belongs to A. I can change the places because or is between, and or is commutative operator that we all know. That if I'm saying that I am teaching in BCA 1 or 3, or I can say that I am teaching in BCA 3 or 1. Like I can change it because or is commutative operator. And so that I can say that X belongs to B union A. So I have taken X from A union B and I got X in B union A. So this is, I can write that A union B is the subset of B union A. And the same way we will take the converse. So in conversely we need to write down like this, that conversely let Y be any arbitrary element from B union A. So now we are taking the element in the second set, which is B union A. So I have taken Y in B union A. So Y belongs to B union A means Y belongs to B or Y belongs to A. So this is I can write Y belongs to B or Y belongs to A. And so I can change the places and I can write Y belongs to A or Y belongs to B because OR is a commutative operator. And so I can say that Y belongs to A union B. So I can say that B union A is subset of A union B. So now I have these two statements. One is this, that A union B is subset of B union A, and second I am having this, B union A is subset of A union B. And so I can say that both the sets are equal. Therefore, from 1 and 2, I can say that A union B equals to B union A. And this completes your proof. Are you clear with this? Yes
Yes, ma'am.
or no?
Yes, ma'am.
Yes. Yes.
Okay. So, if you got the idea, then you can prove the same thing for intersection. Like you can prove A intersection B equals to B intersection A. The only change will be, okay, the change also you need to tell me that what will be the change in proof. So try it the same way I have done for union. You need to do it for intersection. Take one x from A intersection B from here. Take x belongs to A intersection B and show it that x is in B intersection A, and then take y from B intersection A and prove it in A intersection B. Try to write down and you can share with me on WhatsApp also, or you can write in the chat box also. How many of you are trying to write down? How many of you are trying to write down? Only Mansoor. What about others? Okay, Edward. Then this is compulsory for all of you. You need to try at least. If you are stopping somewhere, it's okay. But you need to try, no? There are 21 students in the meeting. Everyone have to write down. Okay, Manish, Rasesh, K1. Okay. Try it and share it with me on WhatsApp. And you just have to tell me that what is the change. What is the major change in both the proofs? I'm giving you 3-4 minutes to prove it. I have received one solution from Edward William, and I really appreciate the solution given by him. This is perfectly correct, and the presentation and all what he has done is fabulous. Everyone should share the solution with me. Okay, Mansoor, X belongs to A intersection B. X belongs to A and X belongs to B. That means X belongs to B and X belongs to A. And so X belongs to B intersection A. This is the one way. The another way you have to take Y belongs to B intersection A. And you can start the converse part. Up to this you have done correct, Mansoor. Okay, so answers given by Rasesh, Manish, Mansoor, Preet. Yes. So here I'm showing you in the screen. See, the proof will be same for union and intersection. The difference is will replace or with and, because intersection is working with and. So here we are taking X is any arbitrary element in A intersection B. So X belongs to A intersection B, which means X belongs to A and X belongs to B. And so I can write X belongs to B and X belongs to A because and is commutative operator, all of us know. So X belongs to B intersection A. And therefore I can say A intersection B is subset of B intersection A. And conversely, we'll have Y is any arbitrary element in B intersection A. So if Y belongs to B intersection A, then Y belongs to B and Y belongs to A. And so Y belongs to A and Y belongs to B also I can write because and is commutative operator. And so Y belongs to A intersection B. And I can say that B intersection A is subset of A intersection B. And from 1 and 2, I can say that A intersection B equals to B intersection A. And this completes the proof. So The change is only that the symbol is intersection is coming in the place of union, and or is replaced by and. That's it. Okay. So the now next is associative law. So for associative law, okay, let me tell you first. Put the set theory right down. Not set theory. First of all, let me ask you this way. What will be answer of this question? I have written in the chat box. Okay. Now what will be answer of this question? I have written in the chat box.
Answer will be 6, ma'am.
Yes, which means the brackets I am changing, the priorities I'm changing. Like in the first of all, I'm multiplying 2 and 3, and then I'm multiplying 1. And in the second, first of all, I'm multiplying 1 and 2, and then I'm multiplying 3. It does not change the answer. So, the same way in set theory, it is called associative law, and that law is saying that for any three sets A, B, and C, A union B union C in the bracket means first of all we'll find B union C and then we'll union A. And first of all we will find A union B and then we will operate it with C. The answer will be same in both the cases. This is what they are trying to say. Associative law. And the same law is for intersection also, that if I'm doing A intersection B intersection C. Okay, this is the example first. So let us see this example and then we'll move forward to the intersection. Okay, so here I am having set A 1 2 3 4, B 2 3 5 6, and C 2 4 5. First of all, find out A union B union C. So for that we have to find out B union C first. What will be B union C for these sets? Okay, B union C will be 2 3 4 5 6 7. Yes, and then A union B union C. What will be A union B union C? Yes, it will be 1 2 3 4 5 6 7. Okay, so this is what I have. 1 2 3 4 5 6 7. Okay, now the next. First of all, find out A union B. What will be A union B for this set? We have these two sets, these three sets. What will be A union B? Yes, it will be 1 2 3 4 5 6. And then what will be A union B union C? 1, 2, 3, 4, 5, 6, 7. Yes, so answers will be same in both the cases. So associative law works. But for this example, from this example, we cannot say that this is the correct statement A union B union C equals to A union B union C. We have to prove it in general for arbitrary element. That we'll see in the next session. And one more thing I want to say you that intersection is also associative. That means A intersection B intersection C equals to A intersection B first into bracket and then intersection C. These two are equal, and this is you can do. Uh, if this example you can do by your own, try it out at your home. Take a screenshot of it. You just verify both the sides. A intersection into bracket B intersection C and A intersection B intersection C. And answers will be same in both the cases. Okay, so proof of these statements we'll see in the next session. Is there any doubt by your side for this session? For this particular session?
No, ma'am.
Anybody? Is there any doubt? Write it in the chat box. If you have any doubt, you can ask me right now. Okay, and those who are new, you share the request to me on WhatsApp and I'll give you all the previous sessions. So whenever you find time, you can go through those sessions. And anytime you get any doubt, you ask me. Okay, attendance I've already taken. Just one more thing I want to tell you that those who have still not said their names in the format given to you, like your roll number and your name, Deepak Kumar, Edward William, Kevin, Manisha, uh, Rasesh, Vedanshi, Vivek Bhatti, Vuso Moyo. You just edit your name according to the format given to you. If uh, you are not aware of it, you just see other students name like Angela, Amit, Santosh, Aditya Raj Singh. They have formatted their name according to the sequence. First of all, number and then your name. This is you have to do from the next session because it will make us easy to take your attendance. That's it. Okay, so thank you everyone. Have a